Hello, everyone, and welcome to NetBrain's webinar, 5 Ways to Revolutionize Ticket Resolution and Why No-Code Network Automation is the Key. So without further ado, I'd like to pass this to NetBrain's VP of Product Marketing, Jason Boudreau.
All right, thanks, Chuck. Thanks for joining us, everybody, today. Today's topic's a big one. It's always relevant, too. It's how to solve problems faster to maintain uptime for your business. We're looking at this today from the perspective of the network ops team, and we're asking how can automation help? So again, my name is Jason Boudreau, and I'm joined by a handful of folks on our engineering team who I'll introduce to you a little bit later in the presentation as well. Thank you again for joining. So why are we talking about resolving tickets? Well, the reason is that a lot of time is spent resolving tickets every day within particularly large enterprise networks. And in fact, almost 2/3 of all the time spent within the network team goes to either troubleshooting network issues or remediating security threats. And that's according to a 2019 Global Networking Trends Survey by Cisco. And one metric for measuring activity against this is by looking at the number of tickets a team sees every day. And over the years, we've had the chance to talk to hundreds of large enterprises about what they're facing. And what we've seen is somewhere on the scale of 1,000 tickets a day for some of the largest enterprises every day. And so there are teams oftentimes with dozens or even hundreds of operations folks to handle this kind of influx of problems. And what we've done is we've analyzed tickets using data from our customers. And we found that not all tickets are created equal, of course. And there's really 3 types. High frequency tickets, these are the ones that are cropping up again and again. They're kind of pesky. They're draining IT resources. There's high effort tickets. Those are tickets that have kind of, you could say, a well-hidden root cause. Very difficult to find the problem, the root cause. It might take an entire team of people hours to find it, sometimes days. I'm sure each of you can probably relate to some war stories like this. And then the most costly are the high impact tickets. And these may be more rare, but when they strike, of course, a large amount of your business or your customers are directly impacted. And so with such high impact to the business, no matter what kind, any way you slice it, the question is, how can automation help? And that's what we're here to talk about today, particularly, again, network automation. So to see how automation can help, let's look at a basic troubleshooting methodology. And the goal here is to identify opportunities for automation. If you break it down to the core elements, you start with a description of the problem. Usually that information is used to begin isolating the impacted infrastructure. And you then formulate some set of hypothesis about what could be wrong. And then ultimately you need to collect some data, analyze some data to test that hypothesis until you can ultimately invalidate it or validate it until you find the root cause. And so another way to look at this is more like a cycle. At the end of that cycle, you really have a desire to constantly improve so that the future problem resolution is happening more efficiently, continuously. And then another kind of piece of the pie I added a nuance here is about collaboration, because many problems are solved through a group effort. And so in today's webinar, I'd like to use this framework to discuss how automation can be applied to various stages of every ticket. And of course, tickets are generated by many sources, whether by an end user, opening a ticket directly or calling the help desk, or by an engineer stumbling across a problem, or maybe even automatically by one of your existing event management or monitoring tools. But one of the challenges is typically when you start to work one of these, you're armed with very little information to get you started. Maybe just a short description, maybe an IP address, just a couple of clues. And so the next thing is to isolate the part of the network that's relevant to this problem description. Maybe it's a site that went down. Maybe it's a path of a slow application that's reported. Or perhaps, maybe it's a switch where an infected server connects to the broader network. And you need to isolate the part of the network relevant for that ticket. But rarely is this straightforward. So taking an application issue, for example, to understand how that application flows across the network, it requires a detailed understanding of the layer 2 and the layer 3 forwarding logic, an understanding of maybe the traffic filtering or the access lists. Maybe that application crosses a data center, and maybe that data center is recently migrated to SDN, and you're just not familiar with troubleshooting that part of the network. And then the tools you're using for performing this trace, typically the command line interface, right, the CLI, it's very linear, very manual in nature. So what you have is just this step here to isolate the sort of the problem radius, this mapping complex traffic flow can take 30 minutes or more easily. And so this is why we see that a network map needs to be dynamic in nature. The goal is to isolate the relevant part of the network sort of very quickly and efficiently. And so a couple of examples, like if you're troubleshooting in issues at a remote site, you just drill into the site map. Or if you're troubleshooting a slow application, you would just map that application flow. Or if there's a maybe a security breach, you would search for the infected endpoint and you would map its neighbors. And so this map provides the right context for troubleshooting all of your diagnostic activities. And the map is really what you do as an engineer, and you're starting to troubleshoot anyways. Maybe you're doing this in your mind because you know that part of the network. Maybe you're doing it on a whiteboard, but this is always the first step into troubleshooting. And so to kind of show what this could look like through dynamic mapping, let's take a look at a live demo to see how this works. And for that, I'd like to introduce Dave Spence. Dave's a senior engineer at NetBrain to walk us through it. Dave, over to you.
Thanks, Jason. So let me begin by sharing my screen. Brilliant, fantastic. So let's begin.
Sorry, I was muted.
That's okay, that's fine. So what I want to talk about now is the key task when troubleshooting, and particularly identifying all of the components which are involved, because often that can take a huge amount of time in the troubleshooting process. Because when you think about it, as a network engineer, most of us, certainly if we're experienced, we're pretty good at actually solving it. But actually, the biggest bulk of the time is actually identifying where the actual problem is. And so typically, if you have a problem, it's a networking problem, maybe between a source and a destination, the engineer will use tools like ping and traceroute, as Jason mentioned, and then find some time finding the network diagrams to begin with. And then once he's actually found them, looking through them, hoping they're up to date and that they are complete. And then all of that can be quite a time-consuming process to actually find out what the problem. And like I said, that's assuming your documentation is accurate. But it can be even more complicated if you've got a mixture of, say, legacy and software-defined networks. But using NetBrain, what we can do, and this is what I'm going to show you now, is we can map a path across both our legacy and our software-defined networks, and we can show all of the devices along the path. So let's make a start. And we're going to take an example here where we have a problem with a particular client over here talking to a particular server. So what I've got here is NetBrain's A to B pathing tool. And we can use that to map a particular source IP and indeed source port to a particular destination IP and indeed port. And again, I can actually do this both ways if I want to. So I'm going to select a source, so that the source I'm going to select is 20.0.0.20. And if you can see here already, NetBrain knows what's on my network, so it's helping me select. So if it didn't know about that, I wouldn't be able to select it. So that's my source, and my destination here is 10.8.1.4. So this is my server. And so let's say the problem was, this is my web server and I've got a particular client over here. And for whatever reason, my performance to this web server isn't as good as expected. So I can just type in the source, I can put in the destination port, and I can click path. And NetBrain will calculate the path for me. Now, what's important to understand here is that this is not like a ping or a trace route. This is much more sophisticated than that. And I want to look at that in a bit of depth, really. So what NetBrain's actually doing, and this is quite key to understanding pretty much everything NetBrain does, is that NetBrain in the back end, once you've set it up and configured it and it's installed, is that NetBrain actually will build up a digital twin of your network. So it knows all about your network, all about your networking devices, your switches, your routers, but more important than that, much more important than that, it will actually understand the internals of those devices, the configuration, but also the forwarding tables, the routing tables, and actually more than that, things like topology databases and all of that type of stuff. So it will know for all of these individual devices, how are they going to forward traffic? So if you look here on the map that we've got, we can see, so this is our client. So if you look at the top there, 20.0.0.10, 20.0.0.10, this is our client. You can see it's a virtual machine. And if we go across here, look, you can see the server. And there's a few things I want to draw out of this. You can see we're passing through a Cisco ACI environment here, and then we're going to a legacy environment over here with just standard switches and routers, and there's our server at the end. Now, again, I want to point out, like I said, this map was drawn out by or created by NetBrain using the actual forwarding tables of the devices. This is more than just the routing tables, because if I click here, what I can see here is the layer 2 path as well. So this is where it really differs, and this is where the real power of NetBrain comes out compared to something like a traceroute. Because if you think about traceroute, most of us, if we've been doing network engineering for a while, traceroute's one of the most common tools that we use. But traceroute doesn't tell you anything about the layer 2 hops. Here we do. Here we can actually see the individual switches as well, because NetBrain knows about the layer 2 forwarding as well. And actually, if you look across here, it's worth mentioning that NetBrain is also aware of other information on these devices. So if you've got things like ACLs, for example, it's aware that a particular ACL might be blocking a particular port or a particular IP address, and things like VRFs as well, which VRF is being used. And it will show all of that information for you nicely on the map. And in fact, you can see here, traffic was permitted by contract subject. It's giving you all of this very, very useful forward information on the map, allowing you to determine exactly what's going on. And in fact, if we had a firewall, for example, or even just a normal router with an ACL blocking a particular port or IP address, that would show up as well. And the path would end there, and you get a nice little sticky note on the map saying this traffic was blocked by this particular ACL. So it's a very quick way of seeing exactly what's going on the network. But the key thing is that what we can now do, and what this is showing us here, and this is quite important, is that we can target our troubleshooting, because we now know these are all of the devices which are involved in the path of our traffic. And that's really key here. So we can start troubleshooting. I'm not going to preempt some of the later demos, but I'm just going to show you here, just if you like to whet your appetite here. And if you wanted to do some troubleshooting here, we could run an overall health monitor on these devices, because we know these are the devices which are involved. We could perhaps run some CLI commands, or we could retrieve some live data. So we can target our troubleshooting just on these devices. And just imagine how long this would take if we're trying to do this manually without NetBrain. I mean, we've discovered this in just a few minutes, and literally within 2 or 3 minutes, we've identified exactly what the devices are, and we're ready to do some troubleshooting centrally from NetBrain. So I want to show you another example. So another example we can do is imagine that we have a device and it's maybe got some flapping interfaces. Now, one of the really useful things we can do with NetBrain, and I mentioned it before, that we build up a digital twin of the network. And this means that we can search for any device in our network, and we can search using maybe the name of the device, its serial number, MAC address, IP address, pretty much any property of that device, even down to a software version running on that device. But I'm going to search, I'm going to be pretty boring, and I'm going to search for a host name, so LA. This 2, so I know this is the switch, say. This is the switch which is causing me a problem, and we can see it's appeared here in the search. And all I need to do is click that, and it's appeared. So it's showing me some useful information about that device. I can see here it's a Cisco switch. But actually, if I just drag it over here, I can begin to create a map. And in fact, if I now just click here on the little red plus sign here, I can start to add neighbors. Now notice that I've got a choice. If I look over here, look, I've got a choice of topologies. I've got layer 3, I've got layer 2. Well, this is a switch, so I'm going to add the layer 2 neighbors. I want to select all the neighbors, and then I'm going to click add to map. And NetBrain's created a nice little map for me. And we can see here, it's showing me all of the neighbors of this switch. And also it's showing me what interfaces they're connected to. So already I've got a nice picture of that switch and its neighboring area. And so I can start my troubleshooting. I've got a flapping interface issue, so I can start troubleshooting on that device, but also its neighbors. Because if you think about this, if I've got a flapping interface, is it really this device, or maybe it's one of the neighbors which is causing this? So I can start my troubleshooting. So what I could do is I could run an overall health monitor. So that's easy enough. I can run this and I can run that, and that will run on these devices. You can see here it's saying 6 devices. So these are the devices on the map. And you can see my options here. I can check input errors, output errors, traffic utilization, look, and I can change the thresholds. Also here, I can look at things like CPU utilization. So I can verify maybe there's a problem, maybe a device is overloaded or something. But also I've got options here in terms of when I want that data. So maybe I want to pull the data regularly over a particular time period, maybe every 2 minutes, and repeat that 10 times for 20 minutes. I could, though, again, I can change that if you look. I can even do that for a number of seconds. Alternatively, I can just pull the data maybe once from the network. Maybe I would just want to pull the data from the baseline or a particular point in time. So I've a lot of options here. But also on top of that, I can actually pull data from the network as well. So I can say, well, actually for these devices, what I actually want to do here is I want to pull the configuration file. I want to pull the routing tables, maybe the MAC tables and the interface information. So I can immediately obtain all of that information from these devices. Now, again, here, the point I'm trying to get at here is all the time we're using our map here as our user interface. So there's no digging into documentation, there's no SSHing using different console applications. We don't have to worry about all of our consoles and comparing them. We can do all of this directly. NetBrains doing this for us directly from this map. Now, the last thing I want to show you here really is just imagine a scenario where we've got an infected endpoint. So let me create a new map here. Yeah. So what I mean by that is maybe we've got a client or a server with a virus, and perhaps it's targeting other devices on the network. So to do this, to examine this, what we need to do is open our one IP table. So here it is, one IP table. Okay, so let's imagine my security or my monitoring solution has identified a particular IP address as our infected device. So I've got a search box here, so I can search for that, because if you look here, there's quite a few entries here, so I don't really want to scroll down. I can do a search, but look at my options. I can search by IP address, MAC address, LAN, DNS, name. I've got all sorts of options here, but I'm going to search by IP address. So 10.104.10.245. Here we go. So I'm going to search for that. That's my dodgy IP address. So let's say my monitoring solution says this is a dodgy IP. This particular client has got a worm or whatever on it. And you can see here, if I expand this, you can see the switch. You can see the switch, and even the port that this device is connected to. Yes, I've got a lot more information here, but much, much better than that. If I drag this IP address over to the desktop, hey presto, NetBrain has created a little map for me. So I've got the infected client here, look, and I've also got the switch, and also I've got the switch port that it's connected to. Brilliant. Now, before I go ahead and say, well, that's it, all I need to do is log onto this switch and shut down that port, I probably want to expand the switch to get a view of the area that it's connected to, just to make sure I'm going to make a bit more of an informed decision. So all I need to do here is I just click the little red plus sign here, select the layer 2 topology, because this is a switch after all. And I want to know here, what are the connected devices? What is going to be the impact of me shutting down that switch port? And so NetBrain has automatically added all of that information to the map, and I can see the immediate environment, all the individual devices, and exactly where they are connected to that switch. So it gives me immediately the context of that. So I can be aware, well, actually, if I'm going to shut down that port, what else that might affect. So I hope you enjoyed that short demo, and I'll hand you back to Jason.
That's great. Thank you, Dave. Pretty neat to see how a network map becomes kind of the UI, everything that you're showing through that, and that you could create, the right map for the right task. Pretty slick. So armed with the map of the impacted network, like we saw, the next task is to start diagnosing for possible causes of what's actually going on, causing whatever the issue might be. So to do this, though, you need a couple of things. First, to formulate the hypothesis, you need knowledge. You need to know what might be the problem, and that requires some wisdom. That requires some experience. There's even different types of knowledge. There's what I would call in the network context, street smarts. And that's really, a thing or two because you've seen a thing or two, and it's really specific to your network. And then there's the book smarts. Book smarts talk about how to troubleshoot BGP, how to troubleshoot OSPF, things that you might learn in a Cisco textbook, and you might get a certification on. These things are more portable from organization to organization. The other thing that you're going to need is then to test your hypothesis. And for that, you need data. Having the right data is really like having the right tool for the job. And live network data isn't always enough. So the reason for that is you also need to know what's normal for any data point. In other words, what's the baseline? And then there's a third kind of data point, and that's really data from a time the event was happening. So for those intermittent issues in particular, where the problem's there 1 minute and then it's gone by the time you arrive to troubleshoot it, if you could capture the data from the moment of the event, it would really go a long way to helping you solve the problem. And you want to be able to compare between these data points, between what's normal and what's happening, or what was happening and what's normal. And most organizations that we talk to struggle with these two components: not enough expertise across their organization, and then two, lacking the right tooling for the right data. And so that's because the tools that teams are using today really aren't custom built to solve this problem. Take network documentation, it's just not a very good knowledge carrier today, like Visio diagrams. There are several important questions a Visio diagram can't answer, like how should traffic flow for this critical application that I'm troubleshooting? Should the traffic be allowed through this port? Is this normal? Is this the primary path or the failover path? So you really, that's where, I mean, you need to have that sort of street smarts in order to be able to answer those types of questions. And then, there's the other kind of documentation teams have, which is like wikis or playbooks. That's really more for the book smarts, if you will. Some of the more mature organizations have playbooks or wikis to standardize troubleshooting best practices that they've built. But they aren't always used regularly. They're not always maintained. And in the end, they're mostly guides. Teams need to know how to execute against those workflows, and it's still very manual. So on the knowledge side, a couple of ways that most organizations we talk to are trying to solve them with documentation. And then on the sort of the data side, we found that 90% of the time, the only tool used for troubleshooting is the CLI, the command line. And those data points that we talked about, you can't get data from, say, 2 o'clock in the morning. So if it's 8 o'clock in the morning and you're troubleshooting a ticket, you can't go back in time and find out what was happening using the CLI. And the CLI won't tell you, how things should be running. Is this the normal state? It won't give you that baseline information either. So how can automation help, right? That's today's topic. As you saw in Dave's demo, when he talked about dynamic map, it was used to isolate the impacted network. There's another advantage of that map, and that's to abstract what I call is abstract network knowledge, particularly the street smarts there, helping to decode the underlying design intent and to understand the network's baseline. And baseline across much more than just the baseline of the configuration, but baseline across literally thousands of variables, including the state and the nature of the performance of the network as well. So there's the map, and then the other piece of the equation that NetBrain employs is called the executable runbook. The goal of a runbook is to abstract those how-tos, the subject matter expertise, or the book smarts. So you might have a different runbook for multicast that your multicast SME could create and share versus another one for QoS, maybe versus a different runbook for the ACI technology that you just deployed. And that's a way to basically codify and share knowledge. And the key with these runbooks is they're meant to be created by the network team, and that's done with no code. So the goal is to basically make knowledge shareable and executable by everyone across NetOps. So armed with the right knowledge through map and runbook, how do you get access to the right data to test the hypothesis about what could be going wrong? So the last ingredient is the data, and NetBrain helps you collect live data faster through the same method that you use today, the CLI, but through CLI automation. And also by accessing data from your existing troubleshooting tools. So you can basically collect all the data in one place in the context of the network map, like what Dave called the user interface being the map. I like that. But NetBrain can also collect that data automatically, triggered at the moment an event is actually first detected. And that event detection is typically happening by your event consoles, your monitoring, 24/7 monitoring, or your SIM, event management consoles. So if you integrate those event tools with NetBrain, what you have is just-in-time automation triggered at the moment an event is detected, and that can be via an API integration that's very powerful. And then the third data point, you can compare any of this data to the baseline, which is really NetBrain's understanding of a normally performing network. as interpreted across thousands of variables, which are really constantly analyzed and baselined on an almost daily basis. One of the most powerful capabilities of NetBrain is its understanding of a normally performing network, allowing you to do a comparison between what is and what should be, which is extremely powerful. So to give us a look at NetBrain's diagnostic automation, I'd like to introduce Rick Larkin, our engineering manager at NetBrain, to run us through some examples. So over to you, Rick.
All right, thank you, Jason. Thank you very much. Let me go ahead and share my screen. Wonderful. So yeah, I have two sort of use cases I'm going to talk through. The first one is actually something that happened on a recent POC with a customer. Actually, they just became a customer on Monday, which is kind of exciting. And then I'm also going to describe a simple, repeatable use case for building simple runbooks for troubleshooting things where there was a significant reduction in MTTR. This is from a large consulting firm. But what I'm sharing here is this is the result of there was a major outage earlier in the fall with one of the major internet service providers, and this is showing you how NetBrain could help perhaps get to the root cause and get you some some answers quickly. So the green path, this is what the path of all internet bound data goes when life is good, right? So it's hitting that primary internet service provider, right? So this is something that is, baselined and is something that is in, in NetBrain, and we understand that, which is great. And then in the blue, this is what happened on this particular event. It was actually during the weekend, right? So it's off hours, which is even, even kind of crummy. And this is also known as a default routing use case, right? You guys probably know that, right? The 4.0 route, when in doubt, go this way. And what happened in the blue is it went to this router and it realized, oh, this is down, so I'm going to reroute you to our backup, which is the secondary internet service provider. And the good news is there was no actual internet outage. The bad news is the people I work with had to spend 6 hours actually troubleshooting this device, troubleshooting the situation, which is kind of crummy. So we had a post-mortem where we basically said, hey, the green is how it is normally. The blue was in fact the actual path, during the event that was going on. But they had this other monitoring system that says the internet was down. So what they had to do is they had to prove it not only to themselves, but they had to prove it to their management, right? And so this is another use case that we like to call MTTI, or mean time to innocence, right? And essentially what they're looking for is this, to say, nope, we're good, right? And then the other thing that was really interesting is that I had a conversation with their senior router guy. He basically designs their network and is the sort of the guru, right, of all things related to IP routing. So I asked him, I said, well, what did you do on this particular, weekend event? He goes, I knew it wasn't a problem. He goes, I logged in, I ran some CLI commands. I saw that the interface utilization was way down, where it's normally hundreds of megabits, and then this was way up. I verified that the route was failed over and good to go. And I'm like, well, geez, why didn't you help, solve the problem? He's like, well, nobody listened to me, right? So I thought it was kind of interesting. And then I said, well, based on what you did, whatever those tasks that you did, to convince yourself that the internet had failed over, that would be a great runbook. And he's like, Rick, I don't need a runbook. I know what I'm doing. I'm like, no, I know you know what you're doing, but wouldn't it be great if you wrote that runbook and then shared it for your tier 1 responders, right? Those folks on the front line. So sort of, to Jason's point, we'll codify the knowledge, make it available for the rest of the network operations team. These guys probably didn't have to burn 6 hours on the weekend, right? And they agreed. They're like, yeah, you're absolutely right. That's a great use case, for runbooks to solving chronic and common problems. And priority 1 outages are always painful, right? And then the other point I want to make here is that this is also, they said that 90% of the tickets that they get aren't network issues, but it doesn't matter. They still have to work them, right? So that's that whole mean time to innocence, or some people say the network's guilty till proven innocent. So they believe that NetBrain will help them get to that root cause sooner rather than later. I'm going to show you another sort of use case. Let me bring up NetBrain here. So we have, one of our largest customers is a large consulting firm, and what they do is they use simple runbooks, and now they've even integrated ServiceNow, to Jason's other point, trigger diagnosis. But even before they had ServiceNow integrated, they did these simple 3-step runbooks, and quite often this is how they got to the root cause, right? So what they would do is they would execute some CLI commands, and sometimes that got the answer. If not, they would go deeper and retrieve even more data, like a mini benchmark. And if that didn't do it, then usually a diff. Right, comparing something, either the current state to the known good state or some previous state, that gets to the root cause. So let me just run through these things real quick. Right, so execute CLI command. So imagine this is a multicast use case, perhaps. And what's nice is we have these predefined templates, for very common issues, routing, switching, VLANs, that kind of stuff. But you can create your own, right? So this is another way to quickly codify knowledge. And essentially what I'm doing is I'm just going to run these almost 10 CLI commands across these two devices, but it takes seconds, right? So having this at your fingertips is wonderful, right? And certainly, routing in a multicast world is a little bit different, right? Star comma G, S comma G than a traditional routing. And then you can even see like sort of some throughput here, the actual performance of this particular multicast group, right? So imagine this is like a market data situation. So I got some data and everything looks fine, so I want to go deep. So the second chapter of the runbook is retrieve live, right? And here, here's, for those of you that are familiar with NetBrain, here's all the data that we gather. So when Jason makes the point about knowledge and data, this is the data that we get. Very, very deep. We essentially model the entire control plane of your network. And in this case, I'm just looking for pieces of information that might help with my multicast troubleshooting. So maybe I want to look at the config. And what's really cool is you can just tweezerize out just a piece of the config. In this case, I just want to see the multicast interfaces. So that's kind of nice, right? And I can see where the RP is configured, right? So that's really helpful. I again can look at the route table. But then again, doing these one-time data pulls, I'm informing the situation, but I still haven't quite solved the problem. So if that's the case, then many times it's just doing that diff, right? It's comparing, these two multicast route tables, either from the most recent one, or in this case, it's the most recent benchmark to August. Let's take a peek at this. And this is good, right? So what's happening is we can see that these four groups that maybe are representative of Thomson, Reuters, TIBCO market data, they really haven't changed in the last couple of months. So that's great. So this is actually a good thing. This is where we're convincing ourselves that this is not a problem, and so maybe it's something else. It's another part of your network. So hopefully this helped explain some of the ways we can codify knowledge. I love Jason's terms of we want to tap into both the street smarts and the book smarts. And then make it easy. So within one click, everybody in your organization can take advantage of that. So thanks, Jason. Back to you.
Cool. So let's continue the journey around this wheel. Let's talk about the collaboration aspect, summarizing a little bit of what Rick talked about. It's an important part of ticket resolution because so many problems, like Rick said, actually 90% sometimes aren't network problems. But knowing that and then proving it can be two very different things. Excuse me, but sometimes it is a network problem, and when it's the network, it's still the question is what part of the network. Maybe it's within the cloud, maybe it's within the data center, maybe it's within a branch office, and each part of the network is probably managed by a different team with a different set of expertise. So managing all these different pieces and getting teams on the same page when you're troubleshooting, it's typically a team sport. And so the question is how to get everybody on the same page. And so what you showed us, Rick, is really transparency is a powerful tool. Transparency, this is what's happening. This is what the state of it is. Even with the runbook on the left side of the map here, the runbook is really a way to automatically document your process as you go about your job as a network troubleshooting engineer to diagnose the network. It's automatically recording your steps in a runbook, and it's also recording the results of that activity. And that makes it very, very easy to share. Maybe if it's an escalation or to pull other people into a conference bridge when you're troubleshooting, very easy to share kind of what you've done and what was the result, and makes operational handoff a lot more efficient. So that's a very powerful aspect, kind of a fringe benefit of using the map as a collaboration hub. So far we've seen here how automation can help. Really, so far we've mapped the impact of the network, we diagnose the root cause, and we help teams get on the same page. Using these tools, we can identify the cause of the problem much faster. A lot of people ask, can NetBrain help fix the problem? And I think that was even one of the questions that we had in the chat so far. Can NetBrain help to basically employ the fix? And there's certainly ways to do that. You can CLI right to a device through NetBrain, or you can use our change module to push that change. Usually you want that to be part of a structured and careful process, but there's different ways you can do that. It's actually not the focus of today's webinar, though. We think the focus is time to identify the problem is about 80% of the challenge. And so today we're focused on really isolating the actual root cause with the assumption that fixing it is relatively easy after that. So instead, what we'll do is next I'll talk about how to improve troubleshooting systematically, how to find root cause faster, and how to scale automation to do that for every ticket, not just a few. And so when we talk about this with our customers, a lot of questions, there's kind of been a couple set of common questions which come up. Who builds the automation? What skills do they need to do that? What automation should we prioritize? But particularly for troubleshooting, like we're talking about today, it's such a reactive thing, hard to plan for it. How do you know what automation to build in advance in particular? And when is the right time for me to go about that exercise to create this automation? So I'd like to tackle those three questions here. First, the best person to build the automation, we think, is the one with the knowledge. This is a recurring theme of today's webinar, the knowledge, whether it's the street smarts or the book smarts. But getting in the way of that is the skills and cultures gap that's very common within network operations today. It's often those with the best network knowledge aren't the coding experts. And those that can code, the DevOps team or the scripting automation team, they typically don't have the networking know-how. So how to bridge the gap? So we believe the answer here is no code automation, in particular, emphasizing the fact that it's no code. And why is that? Because we want NetOps engineers to be able to build it themselves without kind of crossing this chasm to learn scripting. So that's the who of it, right? The actual NetOps engineer. The when of it is, we think the best time to build automation is after a problem is solved and the lessons learned are fresh on your mind. Many teams conduct like a post-mortem analysis to review where they could have done better after a problem solved. So we think this post-mortem is actually the perfect opportunity to enhance the automation. And the idea here is with a few clicks inside the software in just a few minutes time, you can actually create automation which can then be leveraged the next time a similar problem occurs. And this kind of shift in philosophy or mentality will certainly have a dramatic effect over time as you're solving dozens or even hundreds of problems a day or a week, and you're creating automation that can help to systematically improve future troubleshooting events every time. So I'd like to describe an automation, I guess, typically when I talk about network automation and building this kind of automation machine, I like to describe it as an automation architecture, like a conveyor belt. And I imagine on the left side, you have tickets coming in, and on the right side, you have, problem found, ticket closed. And then, this conveyor belt might be running all day, every day, depending on how many tickets you have. Different levels of automation can be applied to move that ticket along its journey, maybe faster or slower. The first kind of automation is something that can be achieved by integrating with your event tool, like I talked about. That's triggered automation, triggered at the time of the event. The other kind of automation is more human-led. It's interactive. It's a lot of what we saw in these different demos, whether it's mapping a path or running some diagnostic activity. There's interactive automation, but then some large percentage of problems are still going to require good old-fashioned CLI-driven troubleshooting. And the goal then is to increase the percentage of tickets automated and basically systematically reduce mean time resolution this way. In other words, reduce the percentage of tickets that are done manually. And you're effectively, by doing that, you're effectively shifting a workload to the left. And this also brings with it fewer escalations, we find. So that's all well and good. It sounds like a great idea, but how do we achieve this, or is this possible? Where do we start? And so to do this, you strive for continuous improvement. It's not a step function that happens one day. You buy an automation solution and all of a sudden everything's automated. It's a process and it's a journey, and most important, it's your knowledge, your unique knowledge is going into that process. And the time to do that, like we talked about, is that post-mortem is a great time to continuously tune that automation. So you're continuously making the flywheel of this automation architecture sort of spin faster, if you will. And so for our last demo, I'd like to introduce Eugene Uwile. So Eugene's one of our sales engineers, and he's going to give you a demo of what it's like to build no-code automation. So Eugene, over to you.
Thank you very much, Jason. I'll be sharing my screen here. So welcome everyone to the demo today here. We'll quickly go ahead and start off. And what I'd like to talk about today is the no-code automation that NetBrain delivers to every customer we come across. So one thing that has been pointed out is each and every time you're trying to troubleshoot, the key issue is looking at specific parameters. At any point in time, every engineer that's out there will leverage, let's say, CLI to be able to go ahead and pull this information out, similar as to what I'm about to do here. For example, I can quickly log into any of my devices here. And just quickly, let's say, for example, we're having a slowness issue. Try and get information for all the interfaces we may have on a particular device. In this particular case, it is very easy for every engineer to actually log into each and every one of the devices you currently have and get that information. In NetBrains terms, you have the ability to be able to quickly gather this information and also be able to document it. So for example, in this case, we may not find any issues. With this, I can quickly go ahead and document this information and have it populated within the NetBrain map. However, I may have to repeat this process all across the board. Not only do I have to repeat this process on this particular device or other devices going forward, I might have to do it for several different interfaces. With NetBrains automation, you are capable of doing this with a few clicks. For example, here, I can quickly go ahead and open up our a window and run some of these commands directly to all these devices at once in an automated fashion. Like Rick had pointed out, we do have some the templates that are built out, but you can build some of your own and quickly just be able to add any generic show commands that have been recommended by your subject matter experts or your architect to collect during similar scenarios. So for example, in this case, I think my show command is missing right now here. So I'll quickly just go ahead and add it there. And what NetBrain allows me to be able to do is automatically run this across this entire area for each and every device we have within our map here and be able to quickly look into those results. For example, I could jump into one of my routers here and be able to look at the version, look at specifically what I have for interfaces, and even focus on specific variables. Now, not only does this give me the ability of gathering this information, it also gives me the ability to come in here and at any point in time, focus on a single variable across the environment. Using our NetBrain parsers here, I have the ability to quickly pick any other variables and automate the process of adding not only the variable onto the map for visibility or decision-making purposes, even also adding an alert here to let me know when none or any other variables doesn't meet the criteria expected within the network. So for instance, in this case, we could actually go ahead and just type in here, name our variable specifically, input errors, click OK, and we could immediately start monitoring that across the board. In this particular case, you'll notice that NetBrain goes through a process of gathering all this information for the interfaces that we currently have here. And if any of them do not match our required criteria of not being equal to 0, NetBrain will quickly highlight that in all those interfaces on the map. So generally, this process may require that you not only look at a single variable, but several different variables. NetBrain allows us to be able to do something similar for those and be able to highlight those on any map at any point in time. For example, when you look at these alerts, you could actually see each and every variable that does not meet that particular requirement highlighted. But the question becomes, how do you scale this to your entire network? And not only do you scale it to your entire network, how do you scale this particular capability to your entire team? NetBrain allows us to be able to do that simply by using specific our automation here to deliver similar capabilities based on the parser library we have on the back end. For example, here, I could quickly go ahead and focus on adding information about the overall performance of this entire area during my troubleshooting session. Not only am I able to quickly come in and get information in regards to my input errors, but I also have the ability to look into collisions, output errors, and quickly jump into any other devices we currently have and gather additional information. NetBrain allows us to be able to also track over time what certain parameters are doing in terms of trends. Now, you may wonder, because we were looking at interfaces, what if a variable is not included on our automation? NetBrain provides a very easy way to be able to add those variables. For example, for this specific automation, NetBrain allows me to be able to come back here at any point in time. And let's say, for example, if you have any transceivers, NetBrain allows me to be able to leverage our parser library here and focus on those specifically. So for instance, in our case, I'll just go ahead and search for optical here. And when that is done, NetBrain allows me to be able to quickly open up that particular information and just be able to add these two in to my data view. And now going forward, once I save this, I could be able to use this in a similar map. In addition to this, not only does this automation allow you to be able to scale the capability across your entire network and across your team, it also allows your subject matter experts, for example, the architect that Rick was talking to be able to add recommended actions to users in the event they see any issues on any area they're working on. For example, in our case here, I have the ability to start looking at the log information here and focus on app down for the specific interfaces we have and devices we currently have within our environment. NetBrain allows me to be able to use a single click at this particular point and the intelligence built into our platform to be able to gather that information and display it for decision-making purposes. Now, that generally covers how we could come from using a single command to be able to gather information. After gathering that information, turn it into something that is automated and scalable across our entire network, and allowing our subject matter experts at any point in time to leverage the results of those automation and their street smarts about the network and book smart to be able to recommend proper actions for our team to be able to effectively resolve issues within the environment. Thank you very much for your time. I'll return it back to Jason.
Cool. Thank you, Eugene. That was great. You're taking us kind of under the covers behind one of those data views. So I'll bring this webinar, wrap things up a little bit. So I titled the webinar, if you remember, was 5 ways to revolutionize ticket resolution. And so I haven't been enumerating those 5, but I'll summarize it with those 5 ways right here. Number 1 is to dynamically map the network. And the reason there was to isolate the impacted infrastructure. We saw in Dave's demo, the first one there, how he mapped an application flow and he mapped around an infected server. So you can basically isolate the impacted network through automation. Number 2 was make that knowledge accessible. Help teams formulate a hypothesis of what's wrong. And then we saw in that second demo how executable runbooks can be helpful to guide maybe more junior engineers through a more senior troubleshooting logic. 3 is implement the right tooling to collect and baseline the necessary data. The purpose there is to test and validate the hypothesis of what could be, right? What could be wrong. And so we saw how NetBrain collects live data through CLI automation. We saw it on the interfaces in a couple of these demos now. How NetBrain can be triggered to collect that data by integration through like an ITSM or with an event management tool as well. Number 4 was develop a culture and develop tools to promote collaboration, to identify the root cause for those really complex problems that require multiple different team members, or maybe within IT or within the network and security teams, et cetera. And then the last one, maybe the most important, is to make all of this possible, to systematically enhance the automation continuously through no code to do better next time. And that was, we saw in Eugene's demo, what it looks like behind the covers of one of these data views. You can just, for someone who's running a data view, you can just click the execute button, it'll collect all the data and visualize it on the map. But what data to collect, knowing what data to collect is really helpful. So someone can basically create that data view and share that data view to make that information highly accessible. And that doesn't have to be very complex at all. We saw how we could do that. So that's the conclusion. I want to thank everybody for joining the webinar today. Thank you again, everybody.
Thank you, everyone. Have a great evening.
Thanks, folks.
Thanks, everybody. Great job, team. Way to go. Thank you.